we're going to be looking at this last method here. This method is the method that has our equation in it just overall for us. So when we have two things that are inverses of each other, what we're going to be doing when we find the derivative is doing the derivative of our inverse is 1 over the derivative of our original function composed with our inverses function. This is fine, but I think it's a little bit easier to think about when it's in terms of two different functions. So if f of x and g of x are inverses, then if I want to find g prime of x, that inverse of f, it's going to equal 1 over f prime of g of x. So this is realistically the function that we're going to be using. So let f be a function defined by f of x equals x cubed plus 2x squared plus 1. Let g of x equal f inverse of x, where g of 2 is equal to negative 1. Find the value of g prime of 2. So we're looking to figure out g prime of 2, which means we are looking for 1 over f prime of g of 2. This problem gives us g of 2 automatically. So I can go ahead and just say this equals f prime of negative 1. So even though I don't know what f prime is, I can take our function f of x and find f prime. So f of prime of x is equal to 3x squared plus 4x plus 0, and I can go ahead and plug in negative 1. So 3 times negative 1 squared plus 4 times negative 1. Negative 1 squared is 1, so I have 3 minus 4, so negative 1. So I have 1 over negative 1, which is equal to negative 1. So our derivative at 2 is equal to negative 1. When we have tables, it becomes a little bit harder. So we still are dealing with our same type of function. So f is a differentiable and increasing function. Selected values of f and its derivative are given in the table below. If g is the inverse function of f, what is g prime of 6? So we're looking for g prime of 6. This means we need 1 over f prime of g of 6. So we are not given g of x as a table in here, but we do know that they are inverses of each other. So when we are thinking about this, we kind of need to think about what are the x values and y values. So one of the things that we know is the value we're looking for, g of 6, means we are looking for a function g with an x value of 6. We don't have an x value of 6 for g specifically. 6 is on our table, but not the x value of g. When we do our inverse, our x's and y's flip-flop. So if 6 is the x value of g, that means it's going to be the y value of f. So now what we're going to do is look at our table and look for which one has a y value of 6. And if I look here, here is my y value of 6, so my x value is going to be 3. So when f has a x value of 3, it gives a y value of 6. When g has an x value of 6, it gives a y value of 3. They're always going to be the reverse of each other. So now I know 1 over f prime of g of 6 is 3, so I'm going to say f prime of 3. So now I can look at my other column. When x is 3, f prime is 2. So we have 1 over 2. Once we kind of know what to look for, it makes this a lot easier. Whenever we have inverses, I always draw these tables to kind of help us out. Thanks for watching.